I am Priyanka Srinaskar. Today I am going to solve some numericals problems of physics of class 10 Icse, and the book I have taken for solving the problems is Concise Physics of class 10 Icse. I am going to solve the chapter 1, that is force numericals problems today. Exercise 1A. Let us come to know about the formula first. Number 1 formula is moment of couple, that is equal to either of the force multiplied by perpendicular distance between the forces. And the next formula we require is W1 equals into N1 equals to W2 into L2. That is clockwise moment equals to anti-clockwise moment. Now let us come to the number 1 problem. The number 1 problem is stated as the moment of a force of 10 Newton about a fixed point O is 5 Newton meter. Calculate the distance of the point O from the line of action of the force. Here the force is given, that is 10 Newton, and the moment is given. Moment is 5 Newton meter. We have to find the distance. If we apply the formula, moment equals to F1 d1, and we places the value moment 5, force 10, and keep the distance as d1. Then d1 will be 5 by 10, that is 0.5 meter. So here we get the result. The distance of point O from the line of action of force is 0.5 meter. This is the solution of the first problem. Now let us come to the number 2 problem. A nut is opened by a range of length 10 cm. If the least force required is 5 Newton, find the moment of force needed to turn the nut. That means the length is given here, that is d1 equals to 10 cm. Look at the unit. This is centimeter. That means it is in CGS unit. We have to convert it into SI unit first. So we divide 10 by 100 to convert it into meter. That means 0.1 meter. And now the force is given as 5 Newton. So the required moment will be force into distance, that means 5 into 0.1, and the unit will be Newton meter. Therefore the required result is 0.5 Newton meter. Now let us come to the number 3 problem. Here a diagram is given. A wheel of diameter 2 meter is shown in the diagram. With axle at O, a force of 2 Newton is applied at point B in this direction. We have to find the moment of force about the center O and about the point A. For about the center O, we have to first solve the problem. Here diameter is 2 meter. That means radius of the wheel is half of that diameter, that means 1 meter. And OB is the radius of the wheel. So we have got the distance as 1 meter and the force applied is 2 Newton. So moment about O will be the force into the radius, that is OB. That means 2 multiplied by 1 and the unit will be Newton meter. Hence the result is 2 Newton meter. Now let us come to the second part. We have to find the moment about A now. Here is the point A. So for A, the distance will be AB. That is the diameter itself. So we have to find the moment by force multiplied by the distance AB. And the force is 2 Newton and the diameter is 2 meter. So the moment will be 2 into 2 Newton meter, that is 4 Newton meter. And in both the cases, the force is applied in this direction. So the movement will be at this direction, that is the clockwise direction. So both the moment will be in clockwise direction. Now the number 4 numerical of chapter 1 Force Concise Physics class 10 Icse. Here also a diagram is given. A force F1 of 5 Newton is acting at point A and another force F2 as of 3 Newton is acting at the point B, and OA is 2 meter and OB equals to 4 meter. At first we have to find the moment of F1 about O. So that will be the force multiplied by the distance AO. That means 5 into 2 Newton meter, that is 10 Newton meter, and the direction will be this, that means anti-clockwise. Number 2, the moment of force F2 about O, and that will be equals to F2 multiplied by OB. Here F2 is 3 Newton and the distance OB is 4 meter. So the moment will be 3 multiplied by 4 Newton meter. And here the direction will be this. That means clockwise. Now total moment of two forces about O. We know that the anti-clockwise moment is considered as the positive one. So I will keep 10 Newton meter as positive one, and the clockwise moment is taken as the negative one. So the total moment of two force about O will be 10 Newton meter plus minus 12 Newton meter. That is 10 minus 12 Newton meter. That is minus 2 Newton meter. Which means that the total moment is 2 Newton meter, and for this negative sign the direction will be clockwise. Now the number 5 sum. Here is also a diagram. Two forces, each of magnitude 10 Newton, act vertically upwards and downwards at the respectively two ends A and B of a uniform rod of length 4 meter, pivoted at the point O, which is the midpoint of this rod. We have to find the magnitude of resultant moment of forces about the pivot O. At first we have to find the moment about O for the upward force. The upward force is 10 Newton and the distance is AO. As we know, O is the midpoint of the rod AB and the length of the rod AB is 4 meter. Therefore, definitely AO will be 2 meter. So, the required momentum will be 10 into 2 Newton meter, that is 20 Newton meter. And the direction will be clockwise. Now we have to determine the moment of force about O for the downward force. The downward force is also 10 Newton and the distance is OB. And since O is the midpoint of AB, so OB will be also 2 meter. So the required moment will be 10 into 2 Newton meter, that is 20 Newton meter, and this direction will also be clockwise. So the total resultant momentum will be minus 20 plus minus 20. Minus sign is taken for the clockwise direction. So minus 20 minus 20 Newton meter, that is minus 40 Newton meter, or 40 Newton meter. For the minus sign, the direction will be clockwise. Here we got the solution of the number 5 numerical. Number 6 sum. Here a diagram is given which shows that two forces, each of magnitude 10 Newton, acting at A and B at a separation of 50 centimeter in opposite directions, and we have to find the resultant moment of two forces about the point A, B and the point O, which is situated exactly at the middle of the two forces. So for the number 1 solution, that is the moment of forces about A. The force is 10 Newton and the distance is 50 centimeter. That is, in meter it will be 50 by 100 and the unit will be Newton meter. So the moment will be 5 Newton meter and the direction will be clockwise. Now number 2 solution. The moment about B. Here also the force is 10 Newton and the distance is 50 centimeter. That means 50 by 100 meter. The moment will also be 5 Newton meter in this case and the direction will be clockwise. Now we have to find the moment about the point O, which is at the middle of two forces. That means first we have to find the moment about O for the first force, for the force at A. That will be, the force at A is 10 Newton and the distance will be 25 centimeter, as the total distance is 50 centimeter and O is at exactly at the middle of these two forces. Therefore the distance will be 25 centimeter. That means 25 by 100 meter. So the moment will be 2.5 Newton meter and the direction will be clockwise. Now moment about O for the force at B. The force at B is 10 Newton and the distance is 25 centimeter. So it will again be 2.5 Newton meter and the direction will be clockwise. So the resultant force about O will be 2.5 plus 2.5 Newton meter clockwise. That is 5 Newton meter clockwise. this is the solution of number 6 sum. Number 7 sum. A steering wheel of diameter 0.5 meter. This is the diameter of the steering wheel of 0.5 meter. Is rotated anti-clockwise by applying two forces used of magnitude 5 Newton. Two forces of magnitude 5 Newton. So this one is the diagram, and we have to find the moment of force applied. Moment of force applied. The formula is either of the force multiplied by perpendicular distance between the force. That is, either of the force is 5 Newton and the perpendicular distance between them is 0.5 meter. So the moment of force will be 5 multiplied by 0.5 Newton meter, that is 2.5 Newton meter. Number 8 sum. A uniform meter rule. We know 1 meter equals to 100 centimeter. So a uniform meter rule is pivoted at its midpoint. This one is our meter rule. Pivoted at its midpoint. A weight of 50 gram force is suspended at one end of it, where should a weight of 100 gram force be suspended to keep the rule horizontal. So a weight of 50 gram force is suspended at one end. And let us consider the weight of 100 gram force will be suspended at a distance of x centimeter from the midpoint. So as per the formula, W1 into L1 equals to W2 into L2, that is clockwise movement equals to anti-clockwise movement. We have to solve this problem. Here W1 is 50 and L1 is also 50. W2 is 100 and L2 will be, this one is x. So the solution will be 50 by 50, 50 into 50 divided by 100, that is 25 centimeter. So the solution will be at a distance of 25 centimeter. Number 9 sum. A uniform meter rule balances horizontally on a knife edge placed at 58 centimeter mark when a weight of 20 gram force is suspended from one end. Draw a diagram of the arrangement. What is the weight of the rule? This is a uniform meter rule. It balances horizontally on a knife placed at 58 centimeter mark. and the weight of 20 gram force is suspended from one end. So this one is the diagram. Now what is weight of the rule? Here we have to also apply this formula. W1 L1 equals to W2 L2. W1 is 20 gram force and L1 is, the total is 100 and the L1 will be 100 minus 58. And W2 we have to find out, that is the weight of the meter rule, and L2 is 58 minus 50. So W2 will be equals to 20 into 42 divided by 8. Solving this one, we will get the W2 as 105. 21 multiplied by 5, that is 1050. That is the weight of the rule is 105 gram force. Today I have solved the problems of the chapter 1 force exercise 1A, the sums from number 1 to number 9. In the next video I will solve the sums from number 10 to number 18. If you like my videos, do subscribe my channel to get the latest updates, and if you like my videos, please like, share with your friends. Thank you so much. That's all for today.